In this video, we're going to be looking at uniform circular motion. Uniform circular motion, as the name suggests, is an object travelling in a circle at a constant speed. The velocity of this object is constantly changing due to the constantly changing direction. So let's have a look. If we draw a vector of the velocity of the object that's flying around here, so this tennis ball, you'll see that the direction of this velocity is constantly changing. But the magnitude or the size of the vector is remaining constant. So we can conclude from this that the speed of this tennis ball is remaining the same, the velocity is constantly changing. For a velocity to change, we need to have an acceleration acting on it. An acceleration is the change in velocity over a time interval. So, the acceleration of this ball is causing it to change its direction. It's not changing the speed of the ball, it's only changing the direction of the velocity vector. So, in order for that to happen, the acceleration of the ball needs to be towards the centre of its travel. So for this uniform circular motion, we have a fixed radius. The tennis ball is connected to a string. The speed is remaining constant. The velocity is constantly changing due to the direction. This is due to a changing acceleration. This changing acceleration has a certain size. Because our speed is changing, we're not accelerating it as in going faster or slower, we're just changing the direction of the velocity. This acceleration is pointed towards the centre of this circle, along the radius. My arm's starting to get sore now, so we can move on. Now, to prove that the acceleration of the object is towards the centre, let's draw some vectors. So let's get old mate Straussy up here, swinging his tennis ball around. So when he's swinging the tennis ball around, we're going to take 2 points. We're going to call point 1 V1 or VI, and we're going to call point 2 VF. So our initial velocity and our final velocity. Let's draw the vectors for them. Okay, now let's take these vectors and find the change in the velocity, delta V. We can do this through vector subtraction. So if we line them up, put an end on end, we can find that the change in the velocity has a direction along the radius of the circle. Now, this change of velocity can only happen due to an acceleration. So we can conclude that the acceleration is, in fact, pointing towards the centre of the circle, along our radius. So, in motion, we know that the acceleration is the change in velocity over a certain time period. So the change in velocity is, as you just saw, delta V. Delta V is the final velocity, take away the initial velocity. So, our acceleration is defined as delta V over delta T. Acceleration is equal to a change of velocity over a time interval. So using our acceleration formula, A is equal to delta V on delta T. If we let our delta T or our time interval get really, really small, we can find out the instantaneous acceleration on an object. Now, in uniform circular motion, we tend to use a different formula. That is, that the acceleration is equal to the speed squared divided by the radius. This formula is known as the centripetal acceleration formula. To see how we use this formula, be sure to check out the live scribe PDFs. Now, there is one more thing I'm going to talk about in this video, and that is the period. So the period is the time taken for an object to do one full rotation of this uniform circular motion. The formula for the period is t is equal to 2 pi r divided by v. So the period is equal to 2 times by pi times by the radius of our uniform circular motion, all divided by our speed. Now we can rearrange this formula and find out the speed of the object. So again, if you want to see how to use the centripetal acceleration formula and this period formula now, check out the live scribes. So the key points from this video. In uniform circular motion, the speed of the object is remaining the same. The velocity is constantly changing as it goes around the circle. The size or the magnitude of the velocity vector is not changing. It is the direction of it. The changing direction is due to an acceleration perpendicular to this vector. So that is pointing towards the centre of the circle. This is known as centripetal acceleration. Acceleration in general terms is defined as a change of velocity over a time interval. Centripetal acceleration can be calculated using the formula A is equal to v squared on r, where v is our speed and r is the radius of the circle. The period, or the time taken for one revolution of the body in motion around the circle, is defined by this formula. T is equal to 2 pi r over v. Alright, and now that's it.